Class 7, Chapter 3, A Peek Beyond the Point.
Introduction. Sometimes, two objects may look almost the same in length, but only one of them fits properly. For example, Sonu sees two screws that look nearly equal, but when he tries to use them in a toy, only one screw fits. This tells us something important. Small differences in length can matter. Whole centimeters are not always enough for accurate measurement. An object may be a little more than 2 centimeters or a little less than 3 centimeters. To measure such lengths correctly, we need smaller units.
Why we need smaller units. A ruler helps us see differences that our eyes may miss. If an object ends exactly at the 2 centimeter mark, we can say its length is 2 centimeters. But what if it ends after 2 centimeters and before 3 centimeters? Then we cannot describe the length using only whole centimeters. We need to divide 1 centimeter into smaller equal parts. On many rulers, the space between 2 centimeter marks is divided into 10 equal parts. Each small part is called 1/10 of a centimeter. So 1 small division is equal to 1/10 centimeter.
Reading tenths on a scale. To read a measurement using tenths, first look for the whole centimeters. Then count how many small divisions come after the whole centimeter mark. For example, if a screw reaches 2 centimeters and 7 small divisions more, its length is 2 7/10 centimeters. We write this as 2 7 over 10 centimeters. Similarly, if another screw reaches 3 centimeters and 2 small divisions more, its length is 3 2/10 centimeters. We write this as 3 2 over 10 centimeters.
First look for the whole centimeters. Then count the small divisions. This screw is 2 7/10 centimeters. Another screw is 3 2/10 centimeters.
Understanding tenths. When one unit is divided into 10 equal parts, each part is 1/10. So 10 tenths make 1 whole unit. That means 10 times 1/10 equals 1. Now suppose we have 34 tenths. We can think of this as 10 tenths plus 10 tenths plus 10 tenths plus 4 tenths. The first 30 tenths make 3 whole units. So 34 tenths is the same as 3 4 tenths. In symbols, 34 over 10 equals 3 4 over 10.
Reading similar-looking numbers carefully. Some numbers may look similar, but they can mean very different things. For example, 4 and 1 over 10 means 4 whole units and 1/10. 4 over 10 means only 4/10, with no whole unit. 41 over 10 means 41/10, which is equal to 4 and 1/10. But 41 and 1 over 10 means 41 whole units and 1/10. So 41 over 10 is equal to 4.1. But 41 and 1 over 10 is equal to 41.1. These two numbers are very different.
Comparing tenths. To compare numbers written using tenths, it is often helpful to convert everything into tenths. For example, 1 7/10 is the same as 17 tenths. 13 1/10 is the same as 131 tenths. The number with fewer tenths is smaller. So when comparing numbers such as 4 over 10, 4 and 1 over 10, 41 over 10, and 41 and 1 over 10, we read each one carefully. 4 over 10 is 0.4. 4 and 1 over 10 is 4.1. 41 over 10 is also 4.1. 41 and 1 over 10 is 41.1. So the increasing order is 4 over 10, then 4 and 1 over 10, which is equal to 41 over 10, and then 41 and 1 over 10.
Convert everything to tenths to compare. 4 over 10 is 0.4. 4 and 1/10 is 4.1. Now we can easily order them from smallest.
Adding measurements with tenths. Let us add Sonu's arm lengths. His lower arm is 2 and 7/10 units. His upper arm is 3 and 6/10 units. First, add the whole units. 2 plus 3 equals 5. Now add the tenths. 7/10 plus 6/10 equals 13/10. But 13/10 is more than one whole unit. Since 10/10 make 1 unit, 13/10 is equal to 1 unit and 3/10. Now add this to the 5 whole units. 5 plus 1 and 3/10 equals 6 and 3/10. So the total length is 6 and 3/10 units.
Another way to add tenths. We can also convert mixed numbers into tenths. 2 and 7/10 becomes 27/10. 3 and 6/10 becomes 36/10. Now add 27/10 plus 36/10 equals 63/10. 63/10 is equal to 6 and 3/10. So we get the same answer.
Another way to add tenths. We can convert mixed numbers. 2 and 7/10 becomes 27/10, and 3/10, and 3/10. We get the same answer.
Adding 3 parts. Now let us find the total body length of a honeybee. The head is 2 and 3/10 units. The thorax is 5 and 4/10 units. The abdomen is 7 and 5/10 units. First, add the whole parts. 2 plus 5 plus 7 equals 14. Now add the tenths. 3/10 plus 4/10 plus 5/10 equals 12/10. 12/10 is equal to 1 whole unit and 2/10. So the total length is 14 plus 1 and 2/10, which is 15 and 2/10 units. Subtracting measurements with tenths. Now let us subtract. Suppose a hand is 12 and 4/10 units long. The palm is 6 and 7/10 units long. We need to find 12 and 4/10 minus 6 and 7/10. But 4/10 is smaller than 7/10, so we need to borrow 1 whole unit. Remember, 1 unit is equal to 10/10. So 12 and 4/10 becomes 11 and 14/10. Now subtract the whole units. 11 minus 6 equals 5. Subtract the tenths. 14/10 minus 7/10 equals 7/10. So the answer is 5 and 7/10 units.
Subtract by converting everything to tenths. 12 and 4/10 is 124/10. 6 and 7/10 is 67/10. The difference is 5.
Subtracting by converting to tenths. We can also subtract by converting everything into tenths. 12 and 4/10 is 124/10. 6 and 7/10 is 67/10. Now subtract. 124/10 minus 67/10 equals 57/10. 57/10 is equal to 5 and 7/10. So the difference is 5 and 7/10 units.
Real-life example with fish lengths. A celestial pearl danio fish is 2 and 4/10 centimeters long. A Philippine goby fish is 9/10 of a centimeter long. To find the difference, convert 2 and 4/10 into tenths. 2 and 4/10 is 24/10. Now subtract. 24/10 minus 9/10 equals 15/10. 15/10 is equal to 1 and 5/10. So the difference in length is 1 and 5/10 centimeters.
Number patterns with tenths. Tenths can also appear in number patterns. Look at this pattern. 4, 4, and 3/10. 4 and 6/10. The number increases by 3/10 each time, so the next numbers are 4 and 9/10, 5 and 2/10, 5 and 5/10, and 5 and 8/10. Notice that after 4 and 9/10, adding 3/10 crosses into the next whole number.
More patterns. In the pattern, 8 and 2/10, 8 and 7/10, 9 and 2/10, the increase is 5/10 each time. So the next terms are 9 and 7/10, 10 and 2/10, 10 and 7/10, and 11 and 2/10. In another pattern, 7 and 6/10, 8 and 7/10, the increase is 1 and 1/10 each time. So the next terms are 9 and 8/10, 10 and 9/10, 12 and 13 and 1/10.
Decreasing patterns. Tenths can also decrease. For example, 5 and 7/10, 5 and 3/10. This pattern decreases by 4/10 each time. So the next terms are 4 and 9/10, 4 and 5/10, 4 and 1/10, and 3 and 7/10. In the pattern 13 and 5/10, 13, 12 and 5/10, the number decreases by 5/10 each time. So the next terms are 12, 11 and 5/10, 11, and 10 and 5/10. Why hundredths are needed. Sometimes even tenths are not enough. Suppose a folded paper has a length between 4 and 4/10 and 4 and 5/10. The length is between 2 tenth marks. So we divide each tenth into 10 smaller equal parts. Each of these smaller parts is 1/100th of a unit. Since one unit has 10 tenths and each tenth has 10 hundredths, there are 100 hundredths in one whole unit. So, 10 hundredths make 1/10, and 100 hundredths make one whole unit. Reading hundredths. Suppose a length is 4 units, 4/10, and 5 hundredths. We read it as 4 units, 4/10, and 5 hundredths. This is more precise than simply saying the length is between 4.4 and 4.5. Now consider the number 1 unit, 1/10, and 4 hundredths. Since 1/10 is equal to 10 hundredths, 1/10 plus 4 hundredths is 14 hundredths. So, 1 unit, 1/10, and 4 hundredths is the same as 1 and 14 hundredths. It is also the same as 114 hundredths. All three forms represent the same value, 1.14.
Comparing tenths and hundredths. To compare tenths and hundredths, convert tenths into hundredths. For example, 3/10 is equal to 30 hundredths. So When comparing 3/10ths, 3/100ths, and 33/100ths, 3/100ths is the smallest. 33/100ths is the largest. Similarly, 5/10ths is equal to 50/100ths. 4/10ths is equal to 40/100ths. So, when comparing 45/100ths, 54/100ths, 5/10ths, and 4/10ths, 4/10ths is the smallest, and 54/100ths is the largest.
Same whole part, different decimal parts. Now compare 3 and 6/10ths, 3 and 6/100ths, and 3 and 6/10ths and 6/100ths. These all have the same whole number part, which is 3, but their fractional parts are different. 3 and 6/10ths is 3.6d. 3 and 6/100ths is 3.06. 3 and 6/10ths and 6/100ths is 3.66. So the smallest is 3 and 6/100ths. The largest is 3 and 6/10ths and 6/100ths. Adding tenths and hundredths. Let us add 15 units, 3/10ths, and 4/100ths, plus 2 units, 6/10ths, and 8/100ths. First, add the whole units. 15 plus 2 equals 17. Now add the tenths. 3/10ths plus 6/10ths equals 9/10ths. Now add the hundredths. 4/100ths plus 8/100ths equals 12/100ths. But 12/100ths is equal to 1/10 and 2/100ths. So 9/10ths plus 1/10 becomes 10/10ths. And 10/10ths make one whole unit. So the total becomes 18 units and 2/100ths. The answer is 18 and 2/100ths.
Adding by converting to hundredths. We can also convert the numbers into hundredths. 15 units, 3/10ths, and 4/100ths is 15 and 34/100ths. 2 units, 6/10ths, and 8/100ths is 2 and 68/100ths. Now add 15 and 34/100ths plus 2 and 68/100ths. The whole parts give 17. The hundredths give 102/100ths. 102/100ths is equal to 1 whole and 2/100ths. So the final answer is 18 and 2/100ths.
Subtracting tenths and hundredths. Now let us subtract 25 and 9/10ths minus 6 units, 4/10ths, and 7/100ths. First, write 25 and 9/10ths as 25 units, 9/10ths, and 0/100ths. But we cannot subtract 7/100ths from 0/100ths. So we borrow 1/10. Since 1/10 equals 10/100ths, 25 units, 9/10ths, and 0/100ths becomes 25 units, 8/10ths, and 10/100ths. Now subtract. 10/100ths minus 7/100ths equals 3/100ths. 8/10ths minus 4/10ths equals 4/10ths. 25 units minus 6 units equals 19 units. So the answer is 19 units, 4/10ths, and 3/100ths.
More subtraction practice. To subtract 15 units, 3/10ths, and 4/100ths minus 2 units, 6/10ths, and 8/100ths, we need to borrow. First, 4/100ths is smaller than 8/100ths, so borrow 1/10 from 3/10ths. 3/10ths becomes 2/10ths. 4 hundredths becomes 14 hundredths. Now, 2 tenths is smaller than 6 tenths, so borrow 1 unit from 15 units. 15 units becomes 14 units. 2 tenths becomes 12 tenths. Now subtract. 14 hundredths minus 8 hundredths equals 6 hundredths. 12 tenths minus 6 tenths equals 6 tenths. 14 units minus 2 units equals 12 units. So the answer is 12 units, 6 tenths, and 6 hundredths.
Decimal place begins. Decimals extend the place value system to numbers smaller than 1. In the Indian place value system, each place is 10 times the place on its right. For example, 10 ones make 110, 10 tens make 100. The same pattern continues to the right of the ones place. After ones, we have tenths. After tenths, we have hundredths. After hundredths, we have thousandths. Each step to the right means dividing by 10. So the place values are 1, 1/10, 100th, 1,000th, and so on.
Understanding thousandths. If 100th is divided into 10 equal parts, each part is 1,000th. So, 10 thousandths make 100th. 100 thousandths make 1/10. 1,000 thousandths make 1 whole unit. Similarly, 100 tenths make 110 because 110 is 10 units, and each unit has 10 tenths. Also, 1,000 hundredths make 110 because 1 unit has 100 hundredths, and 10 units have 1,000 hundredths. Why the decimal point is needed. A decimal point separates the whole number part from the fractional part. Without the decimal point, the same digits could mean different values. For example, 42 means 4 tens and 2 ones. But 4.2 means 4 ones and 2 tenths. The decimal point tells us where the ones place is. Look at these numbers: 705, 70.5, and 7.05. In 705, the 7 is in the hundreds place, and the 5 is in the ones place. In 70.5, the 7 is in the tens place, and the 5 is in the tenths place. In 7.05, the 7 is in the ones place, and the 5 is in the hundredths place. So the position of the decimal point changes the value of each digit.
Reading decimals. When reading digits after the decimal point, we often read them one by one. For example, 0.274 is read as 0.274. It means 2 tenths, 7 hundredths, and 4 thousandths.
Writing decimal numbers from place values. Let us write decimals using place value. If a number has 2 ones, 3 tenths, and 5 hundredths, then it is 2.35. If a number has 110 and 5 tenths, then it is 10.5. If a number has 4 ones and 6 hundredths, then there are no tenths, so we write 0 in the tenths place. The number is 4.06. If a number has 100, 1 and 100th, then the tens place and tenths place are missing. We use zeros to show the missing places. The number is 101.01.
Combining tenths and hundredths.
Suppose we have 8 hundredths and 9 tenths. First, convert 9 tenths into hundredths. 9 tenths equals 90 hundredths. Now add 90 hundredths plus 8 hundredths equals 98 hundredths. So the decimal form is 0.98.
Key idea. Smaller units help us measure more accurately. Tenths divide 1 unit into 10 equal parts. Hundredths divide 1 unit into 100 equal parts. Thousandths divide 1 unit into 1,000 equal parts. Decimals are based on this repeated division by 10. The decimal point separates the whole number part from the fractional part. And when we add, subtract, compare, or read decimals, place value helps us understand the correct value of every digit.
See you then. I will be ready and waiting for the next part of A Peek Beyond the Point. I'll keep the gears turning and make sure to have that good writing queued up for when you return.